The world is affected by many natural disasters, for example, earthquakes. Civil engineers have to work to find solutions that resist the dangerous effects of these earthquakes. But what exactly are earthquakes and what causes them? Underneath the solid rock ground that we stand on, there's hot, molten magma. The rocky ground as we know it is called tectonic plates, which float on the magma. Earthquakes occur where different tectonic plates meet, called fault lines. Tectonic plates are always moving, but they move so slowly we don't even notice. But sometimes two plates can rub together, causing force and pressure to build up, and a sudden slip from these plates causes a release of energy, otherwise known as earthquakes. On Earth, we have the Ring of Fire, a place where there are many active volcanoes and where earthquakes commonly occur. One area deeply affected by the tectonic plate movement in the Ring of Fire is Chile, in South America. But Chile has numerous civil engineering techniques implemented into its infrastructure to develop buildings that can resist the effects of earthquakes. Through this video, I'll go through the three main techniques they have applied. Number 1. Seismic building codes. Each building in Chile is given a code which determines if it can withstand an earthquake or not. Those not accepted by the standards of these regulations are deemed as unfit for use and demolished. The regulation states that all new buildings must be able to survive a 9.0 magnitude earthquake. The building can tilt or crack during the earthquake, and it can even be declared unfit for future use, but it must not collapse. Number 2. A building technique known as strong columns, weak beams. Buildings are held up by reinforced concrete, which are strengthened by the use of a steel frame. If there is an earthquake, the concrete on the beams should break near the end, which dissipates the energy, but the steel frame should survive, keeping the column standing, and hence the building doesn't collapse. Number 3. Base isolation. Buildings are built on a huge rubber base, so it is isolated from the ground to provide a barrier between the earthquake and the building. The rubber deflects the energy of the earthquake through gliding to either side, but does not absorb it. So this means that most of the energy is not transferred to the rest of the building, and so it does not collapse.